Hello, welcome again. Today we're going to look at Geometry Section 8.5, Angles of Elevation and Depression. Alright, starting here. Circus acts. At the circus, a person in the audience at ground level watches the high wire routine. A 5-foot 6-inch tall acrobat is standing on a platform that is 25 feet off the ground. How far is the audience member from the base of the platform if the angle of elevation from the audience member's line of sight to the top of the acrobat is 27 degrees? So the very first thing that we have to do whenever we look at longer problems such as this is to weed out information that we need, information that we don't need, and to draw a picture. So let's make the drawing. And now that we have the drawing here, we can kind of restate some things. So we notice that there is a 5.6-inch tall person, which is 5.5 feet, and that's listed here, and the triangle is SR. The platform that they are standing on is 25 feet tall. Okay, and that's listed as QR there. The audience member is a certain distance away from the platform. Okay, that's what we're going to try to solve is X. And the line of sight from at the top of the acrobat, from the audience member's line of sight to the top of the acrobat is 27 degrees. So using that information, we will apply some trig functions to solve. Alright, since QR, so back to the picture we'll have, since QR is 25 feet and RS is 5.6 inches or 5.5 feet, QS is 30.5 feet, and we'll let X represent PQ, which is from the picture as well. So therefore then, the tangent of 27, which was the angle elevation, and angle elevation is going up, okay, angle of depression is the other one that is going down, was 27 degrees, and we're going to use a tangent, which is opposite over adjacent. Putting the information that we know, we have the tangent of 27 is equal to 30.5 over x, and of course from the lecture the other day, we multiply by x on both sides and then divide by tangent of 27, and we will end up with approximately 59.9. So then it states the audience member is about 60 feet from the base of the platform. So again, we took the real life problem, took the angle elevation, which is from the site, and then solved using trigonometric the functions. Okay, good. Next one. Diving. At a diving competition, a 6-foot tall diver stands atop a 32-foot tall platform. The front edge of the platform projects 5 feet beyond the ends of the pool. The pool itself is 50 feet in length. A camera is set up at the opposite end of the pool, even with the pool's edge. If the camera is angled so that its line of sight extends to the top of the driver's head, what is the camera's angle of elevation to the nearest degree? So again, we must draw that picture to set it up. So let's just take out some things we need to know right away. We have a 6-foot tall diver and on a 32-foot tall platform that sticks out 5 feet. So if I start drawing, and then we have a pool that's some length, it says that it is 50 feet. So let's draw a pool. I have a pool. The pool is 50 feet. There's a camera at one end. There is a platform, and the platform is 32 feet high. There is a diving platform that sticks out from that platform 5 feet, and the diver itself is 6 feet. So we have a little diver here. Okay, we have the diver itself to the camera as the angle elevation. So the triangle that I'm really looking at, we'll put in green here from the top going down over to the right and back up. This is really the triangle that we're trying to solve. Now, the triangle that we're trying to solve has a height of 32 plus the height of the person as 6, so of 38 feet. And it really has a length on the bottom of not 50 feet but 45 feet, because if the entire length of the pool is 45 feet and the diving platform goes 5 feet into the pool, we're left with 45 here. And the question asks, what is this angle of elevation? So we'll call that our x. Okay, now that we have all of that set up, we can do the easy part, which is the mathematics behind it. So we have the opposite and the adjacent side with x, so therefore we know that the tangent of x is equal to 38 over 45. Simplifying then, we know that x is equal to the tan inverse of 38 over 45. And once we plug that into our calculator, we're left with that x is approximately 40.179. Question asks us to give it to the nearest degree, which is of course c, 40 degrees. And there is the solution to the pool problem. Next one. Maria is at the top of a cliff and sees a seal in the water. If the cliff is 40 feet above the water and the angle of depression now, which means down, is 52 degrees, what is the horizontal distance from the seal to the cliff to the nearest foot? Well, let's get our picture here. So we can see we have Maria. She's at the top part here on the left. We have an angle of depression. The angle of depression goes out straight, okay, and then comes back down. Angle of elevation goes up. So if we want to clarify, we have angle of elevation going up, kind of starting down and then moving up. Angle of depression starts up and goes down. So we have 52 degrees for an angle of depression. The cliff is 40 degrees. Sorry, it's 40 feet high, not 40 degrees. And we're trying to find the horizontal distance from where she sees things to the seal. So where she is, horizontal distance from her to the seal. So the picture is laid out. We can solve this one of two ways. We can, or not one of two ways, but with two different pictures. We can use the picture that they have, and we'll put that in red here. Or we could solve just using a blue one, which drops down B to C, and we know that these are the same. This is actually a rectangle that's created with parallel lines on top and bottom here, which is why the alternate interior angles are both the same, 52 degrees. And the sides are all the same. This is 40 on the left as well as on the right, and the top is X and the bottom is X. So really drawing the pictures of angle of elevation and depression can take multiple forms and setups. You just gotta know what you're doing on either one. Alright, once we have the picture all set, which we do, then we'll solve here. So since A and B and DC are parallel, the two angles are also the same by the fact of the alternate interior angles theorem. That's what I just said. Alright, let's solve then. Let X represent the horizontal distance from the seal to the cliff, DC. So we have the tangent, and the tangent of 52 degrees is equal to 40 over X. Simplifying and solving, we have X equal to 40 over tangent of 52 degrees, which leaves us with approximately 31.3 as the distance from the cliff to the seal. Alright, next problem here. It says Louisa is in a hot air balloon 30 feet above the ground. She sees the landing spot at an angle of depression of 34 degrees. What is the horizontal distance between the hot air balloon and the landing spot to the nearest foot? So we have a hot air balloon that's up in the air. So we'll put a little balloon here. Balloon. There we go. Hot air balloon in the air. She sees the landing spot at an angle of depression of 34 degrees. So let's just project out, project down to a certain spot, and project going at a diagonal. So she claims that this is her angle of depression, being 34 degrees. It says that she is 30 feet above the ground, so with the same being on both the left and the right, if this is 30 feet, this is as well 30 feet. So my triangle is a 34 degree angle in the top part here. and 30 feet for the side. Wants the horizontal distance, so we have X on top. So I solve them with the triangles flipped. You're more than welcome to draw the green triangle in and have the bottom be 34 degrees, have this be X, and to solve that works out just fine too. Either way, once we have that, we have the opposite side being 30, so therefore we set up our trig function. Tangent of 34 is equal to 30 over X. We need to multiply it by X on both sides, and we have X tangent of 34 is equal to 30. Divide both sides by the tangent of 34, and we have X is equal to 30 divided by the tangent of 34, which is approximately, once we plug it into our calculator here, 30 divided by tangent of 34, approximately 44.47, and they want it to the nearest foot, so therefore that will be C, 44 feet. Good. Next problem.